Hi and welcome to part 2 of working on the command line. In this module we will have a look at parents and children and exporting variables. We'll also have a look at some more commands and we'll finish with quoting. Now there's an important technique you should understand when it comes to shells and variables. First, when you run a command that is not a shell built-in but an external command on disk, the following thing happens. Let's say we start working in a bash shell. When you run any external command, the process that you run it from will be copied. This is referred to as a fork, and then the bash program in that process will be replaced by the command you want to run, by means of the exec command. So in the case of ls, the exec ls command will replace bash with ls and then execute it. Once it's done, the command exits and you return to the original process. Officially, this is referred to as a parent process and a child process. Another way of demonstrating this would be to simply start a new bash shell from the current one. So we're in the bash shell and we run bash. So we started a new shell from our existing bash shell. When we run ps-f, which will give us the list of our processes, using the option -f will display multiple properties of the processes that we currently own. As you can see, we have a process with a PID, which is a process identifier, and a PPID. This PPID is the parent process ID. This proves that we started a new process as a child process. So the second bash shell is the child of 2692, and the ps command, in turn, is the child of 2711. When we exit and run ps-f again, then we see that we're back in our initial bash shell. Also we see that the ps command itself was forked once more, and it was executed in a forked shell and then exited, because we can continue working. Now if this was not fully clear, don't worry, we'll get back at this in the module on processes. It is important to know, however, that when you run an external command, it is by default run in a child process. And this has implications for your variables. So when you create a new variable with a value, this is a local variable. This means that the variable is local to the shell. This also means that when you create a child shell, that this variable is not present in that new child shell. For example, when you create a variable number with the value 10, you can echo its value. And when you create a new bash shell and echo its value again, you notice that it is not there. Why not? Because it doesn't get exported to the new child shell. So how can we get variables to be passed on to the child processes? This can be done using the export command. So say we're in process 1, 2, 3, 4, 5 and set number to 10. Then we export number and we create a new bash as a child. And in the new child shell, this variable number will still have value number 10 because it's been exported to the new child. We can also give the variable a value and export it at the same time by simply running export variable equals value. With regards to this, there are two commands that are related here, the set command and the env command. The set command will list all variables, local and environment variables, and the env command will only list all exported or environment variables. A last example, we create a variable called zvar and give it the value 1. Then we check this is a local variable that will not be passed on to the child process. So we run bash, we echo the contents of the zvar variable and we see that it's empty. So we exit the child again, then we run the set command and see that zvar is a variable that has been set. And when we run the env command, the zvar variable is not there. But now we export it and run env again. And now we see that zvar is actually exported. So we run a child shell and run echo $zvar and see that this variable has been taken along into the next child. So we exit And if you want to unexport a variable, we can run export-n and then the variable name. And to get rid of the variable altogether, we run unset variable name. The very last thing we will look at in this module is quoting. Now there are three types of quotes that can be used: single quotes, double quotes, and back quotes, also called backticks. These back quotes are pretty special, but let's first look at single and double quotes. Single and double quotes keep parts of a string together. So for example, if I say my var equals 10 space 11, I get an error message because after storing the value 10 in my var, the shell tries to execute command 11, which is obviously not what we really want. But when we use double quotes, then this will not happen because it will simply treat it as a single string. The same goes for single quotes. You use single quotes to surround the entire string, including the space, then that will take the values as one single value. But what is the difference between single and double quotes? Single quotes are stronger, so to say, because single quotes take away the meaning of any special character and simply print it the way it is. Not so with double quotes. Double quotes do not print the $, the backslash, and the backtick. So again, single quotes literally print all characters, whereas double quotes do not print $, backslash, and backtick. These characters will be evaluated instead of printed. The $sign displays the contents or evaluates the contents of a variable. The backslash escapes the next special character, and the backtick runs command substitution. Now, maybe this can all best be explained by demonstrating it. Imagine you have a car that only costs $5 and you want to print the car and the price. So we fill the variable car and that's it. So let's say we have a BMW. Then when we use double quotes, we see that it does not print the $sign but evaluates it. This is nice for the value of the variable car, but we want to literally print that it costs $5. Since $5 is non-existent, it will not print anything. So this is kind of a problem. If we use single quotes, the reverse happens, since it will not evaluate the $sign. So $car and $5 are literally printed. Now we can combine double quotes with the backslash. With the backslash, we escape the $sign so that it simply gets printed as is. And finally, let's have a look at the backticks. This is kind of an abstract thing, in that it means that the output of a command will be used in the command that it embraces. So you run a command that holds another command. If you backtick that second command, it will be executed and the output will be used in the first command. So let's do that. The uname command prints the name of your kernel. When you add the option -r, that will print the release that you're running. So, as we can see, we run Linux Enterprise Linux 7. Now, if we want to have this printed in a full sentence, we could go like this. And we see that the two commands are just treated as text in the echo command. Now, when we use backticks around the two commands and run it again, then we see that it uses the output. So we're running Linux Enterprise Linux 7. So this looks a lot better. Now, to confuse the enemy, there's another syntax that can be used instead of the backticks, which is a $ and then round brackets, which is a newer syntax with the same functionality. So in summary, we discussed parent processes and child processes and saw that external commands will generate a fork to create a child process. We looked at local variables and environment variables or exported variables with the command export, set and env. And we dealt with quoting, single, double and command substitution with backticks. Now if you like, you can pause the video and have a look at the following commands.